Hello, this video is on solving using completing the square as a strategy. Before we can jump into what this strategy looks like, we do need to review what a perfect square trinomial is. Hopefully this rings a bell. It is something we studied back in January when we were learning about factoring. It is a special case of a trinomial. So we're going to do an example just to see what's going on and why it is a special case. So the example we're going to look at is x squared minus 18x plus 81. So we're just going to factor this like we normally would. So I put my 81 x squared up top minus 18x in the bottom. Same rules apply, so it's going to multiply to give us 81x squared and add to give us negative 18x. It looks like negative 9x and negative 9x would work. From there I'll fill in my box, so I'll have x squared, 81, and then I'm going to have a negative 9x in each box that's left. Then I'll just work that out the rest of the way. So to get my x squared I need an x and an x, and then I have to multiply by a negative 9 and a negative 9. So if I rewrote this equation in factored form, I'd get x minus 9 times x minus 9. And we would just simplify that down to x minus 9 squared. So this is an example of a perfect square trinomial because I can write it as one binomial squared. So this is what we're going to use to help us when we are using the strategy of completing the square. So a couple things I want to point out. If you look at our original equation, so right here, there's a couple key relationships that you're going to want to notice. This number here, so our b term, so in this case negative 18, if I take half of that, that gives me the minus 9. So that'll always be true. So I can take my b term and take half of it to get what is going to go right here. And now, if I take that negative 9, I can then square it. So if I do negative 9 squared, that gives me my c term of 81. So the b term and the c term are going to be related to what's in our parenthesis in factored form. Let's try a couple more examples. What I want you to do is, on the left side we have these quadratic equations in standard form, and on the right side we're going to rewrite them in factored form. So I'm going to do a couple examples with you, and then I would like you to pause the video and try a couple on your own. If you do get stuck, keep in mind you can always use diamond and box, but I'm going to use the patterns we talked about on the previous slide to help it go a little bit faster. So in this case, it's always going to start with a parenthesis, and these are all examples of perfect square trinomials. So all of my answers should be one binomial squared. So if you think back to the previous example, I said you take half of the b term, so in this case the b term is 6. We take half of that, which is a positive 3, and that's what's going to go in my parentheses. So my factored form is x plus 3 squared. If I try it for our second one, let's start with x. My b term is a positive 8, so I take half of that, plus 4. That'll be squared, and then for the 4, if I squared it, would give me the 16, so that's good. So now I want you to hit pause, try the rest of these on your own, and then come back and check your work. Alright, hopefully you tried those, and are coming back to check your work now. Moving on to the next one of x squared minus 10x plus 25. Always going to start with the x in the beginning of the parentheses, and then I'm going to take half of that b term, so half of negative 10 is negative 5. So that would be that factored form. Ooh, next one I have to go the other direction. Well, I know I'm going to have an x squared if I multiply it out. I know that this minus 7 is half of my b term, so that must be minus 14x. And then I know I need to square that minus 7 to get to the c term, so plus 49. Alright, moving on to the next one, x squared minus 20x plus blank. And on the right side I have x minus blank. Well, I know that I need to take half of my b term of the negative 20 to get minus 10 here. And then I know I need to do 10 or minus 10 and square it, which gives me 100 here. So I can still fill in some missing puzzle pieces here. Next one, half of 16 would give me 8 here. I square it and get 64 there. And these patterns hold true for all perfect square trinomials. Next one, ooh, they just gave us a b. So we're just going to do half b, because we would take half of it and then square that. So 1/2 squared is 1/4 b squared. And then the last one, half of 7 is 3.5. And I would square that, and that would give me 12.25. All right, so right now this probably seems kind of random. Like, why are we practicing perfect square trinomials? But using perfect square trinomials will help us learn our next strategy and will be something that you might want to use when you are solving quadratics. So some people call this the genius method. It's also known as completing the square. So what you do is you take a trinomial like this, x squared plus 12x plus 32, that can't be factored with whole numbers, or maybe it doesn't factor nicely, and you're going to turn it into a perfect square trinomial. So all they did here was they took the 32, and we'll go through more examples, and they subtracted that to the other side. That's how it got to the right. And now all they're saying is we're going to add some number to both sides. And it's okay to do that because we're going to add it to both sides. So in this case, if I use my rules from before, half of this 12 would give me 6. So that goes here. And 6 squared is 36, so then I would add 36 to both sides. So now I have x plus 6 squared, and then negative 32 plus 36 is 4. Now the cool thing is from here, I can jump into solving using square roots. Okay, so the biggest thing is that completing the square means we're going to create a perfect square trinomial to make solving easier. So we already reviewed what a perfect square trinomial is, but if you want a couple more examples, another one would be x squared plus 8x plus 16. And in factored form, that would be x plus, well, I take half of that to get 4 square, or give me 4, and then I would square that to get the 16 there. Another example would be x squared minus 12x plus 36. If I was going to factor that, I'd get x minus 6, that's half of negative 12, and square that. Okay, so when you solve these, the thing you have to remember is that your equation has to be written in the form ax squared plus bx is equal to c. So what that means is the x terms are on one side together and the number is on the other side by itself. So this might look like x squared plus 4x is equal to 0. Could also look like 2x squared plus 6x is equal to 10. But the important thing is the x's are on one side, and then the number is by itself on the other side. For those of you who like having some concrete steps to follow, here are 5 steps. Those of you who like looking at the examples, those will come after this. So step 1, make sure the coefficient a is equal to 1. So that means the number here has to be equal to 1. So take out a GCF if you need to. Step 2 is to put the x terms on one side of the equation and anything else on the other side. Talked about that in the last slide. Step 3 is compute half b squared and add this number to both sides of the equation. Step 4, factor the trinomial as a perfect square. And step 5 is to take the square roots of both sides and simplify. Okay, I like to jump right into some examples so we can see what this looks like. So step 1, for those of you who like to follow the steps, says to make sure the coefficient a is equal to 1. In this case, it is, so we're good in the x squared plus 14x equals 15. Step 2 is to have the x terms on one side and everything else on the other side. We are also good there. Okay, so now we need to figure out how to force this left side here into a perfect square trinomial. So what we need to do is we need to add some number to both sides to make that happen. So I'll have x squared plus 14x plus some number is equal to 15 plus that same number. Because whatever I add to one side, I have to add to the other to keep it balanced. So keep in mind the goal is to turn the x squared plus 14x plus a number into x plus something squared to make our life easier. So to get the number that goes in the parentheses, I have to take half of 14, which is 7. That's what's going to go there. So I have x plus 7 squared. I'm going to square 7 to give me 49. So 49 is what I'm adding to both sides. So now x squared plus 14x plus 49 becomes x plus 7 squared. And 15 plus 49 is 64. Now I can move on to solving using square roots like we learned yesterday. So I'm left with x plus 7 equals plus or minus 8. And then I'll solve each equation. So I have x plus 7 is equal to 8, and x plus 7 is equal to negative 8. Subtract 7. I get x is equal to 1. Subtract 7 in my second equation. X is equal to negative 15. Okay, let's look at our second example. Negative 2x squared plus 12x minus 20. That a term has to be 1. So I need to divide out a negative 2 first to make that happen. So then I'm left with x squared minus 6x plus 10 is equal to 0. Next step is to get the x terms on one side, and I have to move the number to the other side by itself. So I'm going to subtract 10. So I'm left with x squared minus 6x is equal to negative 10. Now I need to figure out what I need to add to each side to make it a perfect square trinomial. So my goal is to make this side into x and then some binomial squared. So if I do that, half of negative 6 would give me minus 3. And then I will square negative 3 to give me 9 that I need to add to both sides. So then I'm left with x minus 3 squared is equal to negative 1. So now I'm into that one binomial squared, and I can solve using square roots. Ooh, okay, so I just ran into an issue here trying to take the square root of a negative, which does not work. That's a clue. Well, not a clue. It tells me that there are no solutions. So I don't need to go any further. I can stop there. So if you ever get to the part where you're taking a square root and it's a negative, that doesn't work. There are no solutions. Okay, 2 more examples. For this one, my a value is not 1. So even though 3 is not a GCF, I do need to divide it out. So if I divide out 3, I'm left with x squared. I'm going to leave this as minus 10 thirds x, and that's going to be equal to negative 1 now. Okay, don't let fractions stress you out. It works the same way. If you want to take a calculator and turn that into a decimal, you could do that also. So I'm going to keep in mind, again, I'm trying to make that left side into some sort of perfect square trinomial. So I have to figure out what do I add to each side to make that happen. So I'm going to take half of my b term, so half of negative 10 thirds would be negative 5 thirds. So that's what is going to go in here is minus 5 thirds. And I need to multiply that by itself or square it to figure out what to add to each side. So negative 5 times negative 5 is 25. And 3 times 3 is 9. So I'm going to add 25 ninths to each side. So left side will turn into x minus 5 thirds squared. Right side, if I do negative 1 plus 25 ninths, that'd be the same as negative 9 over 9 plus 25 ninths, so 16 ninths. And now, like before, take the square root. So I have x minus 5 thirds is equal to plus or minus. When I take the square root of 16 ninths, you take the square root of the top and the bottom. So that gives me plus or minus 4 thirds. And then I'll break it apart like before. So x minus 5 thirds is equal to 4 thirds. And x minus 5 thirds is equal to negative 4 thirds. add 5/3 to both. This is not a big deal because they have a common denominator, so I get x is equal to 9/3, which is 3. Second one, I'll add 5/3. I have -4/3 plus 5/3, which is 1/3. And those are my two solutions. All right, let's try the last one. My a value is 1, that's good, but I do need to add 2 to the other side. So now I have x squared minus 2x is equal to 2. I'm going to try to figure out what to add to both sides. I like using the next step as a guide. I'm going to have x something in there squared. So I'm going to take half of -2, which is -1. And then I have to square -1 to figure out what goes here, which is +1. So I get x minus 1 squared is equal to 3. And now I'm going to go ahead and solve using square roots. So square root that. X minus 1 is equal to, and here square root of 3 is not a perfect square, but I'm going to use a calculator, which gives me positive or negative 1.73. And then I'll just solve both of those. So x minus 1 equals 1.73. X minus 1 equals negative 1.73. Add 1 here. I get x is equal to 2.73. Add 1 on my other side. And I get x equals negative 0.73. Two solutions. Thanks for watching.